Okay, hello everyone, this is Vimal Upadhyay. In this video, we are going to discuss about momentum and laws of motion. The laws of motion by means we will going to particularly discuss the second law of motion. So a lot to know in this video, so watch this video till last and let's start the topic. The first topic that we are going to discuss is momentum. In simple word, it is inertia in motion. If you don't know what is inertia in motion, I have discussed that in my previous video. So go and check that video and then come. So definition of the momentum is product of mass and velocity. Product of mass and velocity. That is, it is denoted by P, and that is P is equals to M into V. Let me give you an example so that you can understand better what is a momentum. Suppose you are playing cricket and suddenly batsman hits the ball and you are standing here for a catch. As soon as you take the catch, you feel certain impact on your hands. Why you feel that impact? You feel that impact because that ball has momentum. And why that ball has momentum? Since the ball is moving, that ball is moving and the ball has some mass, so it has a momentum. So which body is having a momentum? All the moving bodies with a velocity, constant velocity with a constant mass has momentum. So product of mass, so by definition we can say that product of mass and velocity is momentum. Unit of momentum is kg meter per second. It is denoted by P, and P is equals to mv. Now let's see an example. V is equals to mv, and that means with increase in mass, momentum increases, and with decreases, momentum decreases, provided velocity should be constant. And same goes for velocity. If you increase the velocity, momentum will increase. If you decrease the velocity, momentum will decrease, provided mass is constant. Let me give you an example for a better understanding. Suppose there is a walls, and a car is moving towards it, and you are running towards it, and by somehow you are both having the same velocity. Both collides with the wall. You will find that this car is somehow able to break the wall, but you will end up hurting yourself. Though you have both the same velocity, the momentum possessed by this car is more than you. That's why momentum depends on mass, as you can clearly understand. Now let me give you another example related to velocity. A bullet has very high velocity. Due to this high velocity, it can possess more momentum than the car that we are discussing about, and how much impact it can generate, as you know. So let's move to our next topic. So our next topic is Newton's second law of motion. It states that rate of change of momentum is directly proportional to the applied force. Rate of change of momentum is directly proportional to the applied force. So F is equals to ma. But where this a comes from? We are talking about momentum. Momentum has mass and velocity, but where does this a comes from? Let's see how this a comes from. Now we are having F rate of change. Let's check the rate of change of momentum. This is the delta sign. We can say that rate of change of momentum is P2 minus P1 divided by T. P2 minus P1 divided by T. P2 is final momentum, P1 is initial momentum, T1 is the time taken to change that occur. Now P2 can be written as mv2 and P1 can be written as mv1. Remember that we are taking mass as constant. Now mass is constant in both, so we can take common from both now. So V2 minus V1 divided by T. Now v2 minus v1 by t, this is acceleration, this is nothing but acceleration. So from here you can say that the rate of change of momentum is nothing but mass into acceleration. Now let's come to the definition statement of the Newton's second law of motion. It says F is directly proportional. F is directly proportional to mass into acceleration. We need to remove this proportionality sign. What we will do, we will add a constant. So it will become kma. K is the constant to remove proportionality sign. If we take F is equals to 1, m is equals to 1, a is equals to 1, then k will automatically will equals to 1, and this k equals to 1 we will put here. So it will become F is equals to ma. This is the mathematical form of second law of motion. That's it for this video. We will continue our discussion in our next class.